And here we go. So we are on 1A.5, connecting growth factors to percent change. Okay. This is a 3-part section. Okay. Part 1 is what we're going to start with, is exploring an exponential situationship. Okay. And then part 2 is writing a function model with 2 data pairs. And then part 3 is understanding compound interest. That's the things we're building up to. Got it? So breaking it down so that it doesn't seem overwhelming and like a lot. I'm going to make sure I have that because if not. All right. So up first, we're going to talk about exploring an exponential situation. And in order to explore exponential situations, we're going to review some concepts of exponential situations. All right. This is your title. So this is 1A.5, part 1, exploring an exponential situation. And we're on page number 10. Okay. So on the next slide, you're going to see information. However, I do not want you to write down everything. I'm going to underline and highlight what's important. Got it? So do not write down everything. If you can't see for whatever reason, you can always click on the link from your computer and you can see it right along in your face. And you can zoom how much ever you like. All right. All right. Here we go. So it says, what are some of the key features of exponential functions? So what we're writing down here are highlight key features of exponential functions. Okay. We're pulling these functions from our Freyer model notes that we wrote in our notebook. Our very first set of notes we took on pages 1, 2, and 3. So on page 3, we talked about an exponential function. Okay. Key thing from an exponential function is that the exponential function can be a growth or a decay. Okay. And the key thing here is that it's equal factors. It's a lot of this. Pretty much you're writing down this whole sentence. I lied to you. Over equal intervals. That's the very most important thing that you need to understand. It has to be equal factors over equal intervals. Okay. Factors. What does a factor mean? What is the definition of a factor? I can hear?
According to me.
No. Mathematically, what is a factor?
It's a number that's it's a piece of an full number.
I will take that. A factor is a something that you're multiplying by, right? So for example, if I have the number 6, 2 and 3 are factors of 6. Does that make sense? Because 2 times 3 can equal 6. So when it says equal factor, that means that you are multiplying by the same number to get from one output to the next. Does that make sense? And when it says over equal intervals, that means that you're counting by an equal value. So whether you're counting by 1, 2, 3, 4, 5, 6, or you're counting by 2, 4, 6, 7, 8, or you're counting by 5, 10, 15, 20, 25, those are all equal intervals because I'm going from one input to the next by the same amount. Yes? Yeah? Okay, that's what that's telling you. All right, next, it says exponential functions have the form f of x equals. So for some reason, this got jumbled. So we're going to write this in a better format. So what's important is f of x equals a times c to the x. It's an exponential because your x is the power, right? It's an exponential because your x is the power. Your c variable is called your growth or decay factor. And your a represents your y-intercept. So c is your growth or decay factor. And your A is your growth or, I'm sorry, your A is your y-intercept. So for example, if I said that I have y equals 2 times 3 to the x. And I'm going to ask you guys, what is my growth factor? What should you all say? I didn't hear everybody. Let's try that again. What is my growth factor? Why is it 3? It's your C, and
Scroll.
it's growing logically, right? If I have 3 times something to the power, it's growing, correct? What is my y-intercept?
A.
But for this example,
2.
it's going to be 2. 0, 2 is my y-intercept because it's in the place of my a variable. Make sense? Okay, so that's our y-intercept and our growth factor. Cool? All right. Now, when we are determining logically, y'all did a fairly good job about the growth factor, but mathematically, what you're looking for when you're determining whether you have a growth factor or a decay. So it's a growth or a decay, and it's based off of your C value. So it's a growth if your common ratio is greater than 1, meaning I'm a growth if C is greater than 1. Make sense? Your decay functions have a common ratio between 0 and 1, meaning my C is greater than 0, but less than 1. Okay? So those are the main things so far that we should have written down in our handy dandy notes reviewing exponential functions. Okay? Questions, comments, concerns? Cool. Okay, so we're going to apply exponential functions in a real world situation. If you take a look up here, PowerPoint doesn't allow me to play YouTube videos anymore, so I have to go directly to the YouTube, which is fine.
Let's say you want to buy this white Jeep Wrangler because, hey, it's summer and you're feeling frisky. Well, this model will run you nearly $50,000. But after you drive it off the lot, even just after 1 minute, it'll be worth $45,769. Now, why is that? The more you use a car, the less valuable it becomes. That's just simply depreciation, but that doesn't really answer why we lose 10% off the bat. Initially, when a car is listed at a retail price, there's actually a markup that's involved from the dealer to you, and this markup includes what the dealer is going to make. It also includes licensing fees and taxes that you're going to pay for the car. Once you drive it off the lot, though, the car becomes used, and the dealer's not going to want to buy it back from you at the retail price. They're just willing to pay the wholesale price because that's what they can get it for from the manufacturer. To get the best value on a car, always try to buy a used car after 3 or 4 years. That's when most of the depreciation has already occurred. Now, surprisingly, the Jeep Wrangler is one of the least depreciating cars, so that's good, but other cars aren't so fortunate. Let's say you want to buy this white Jeep Wrangler.
All right, did you learn something from that? No? No one learned anything about car depreciation, best models, huh? You don't like cars? Okay, stay on your feet then, buddy. For the rest of us that like cars,
I have the card.
that's what hopefully you took away. But the most important thing there was the graph. Oh my gosh, look at that. Isn't that crazy? What does this graph show? An exponential what? A what? A decay, an exponential decay. Here is a real world application of an exponential decay. So as we watch this, we learn that cars lose appreciation, right? Most cars do. Now, if you have a luxury or a classic or some of those things, that's a different story, right? But the average Joe vehicle is going to depreciate as soon as you drive it off of the lot. All right. And the rate that and because it depreciates so quickly, that rate is what we call an exponential decay. All right. So what you're going to do, or what we're going to do today, is we're going to analyze the depreciation of a vehicle. So one of the most commonly used resources for buying a car by consumers is Kelley Blue Book. It's like the oldest book, or people who collect data over time of vehicles, how they last, their features, all that good stuff. It's called the Kelley Blue Book. And in the Kelley Blue Book, it says that we have a car that costs $18,000 brand new. However, that car loses 20% every year. And in our notes, we're going to make a table. The reason why we're going to make a table is so that we can analyze it and figure out what is its ratio of excessive values, AKA what is its growth factor or its decay factor. Does that make sense? All right, so we're going to talk about finding the value of something. If I'm looking for the value, I'm going to first state how the value is set to begin with. So you're making this table in your notes, and we're going to fill in. We're going to do the first couple rows together, and then you're going to do the rest. So at year 0, how much is my car? 18,000. So that's my year 0. So year 0 is 18,000. It told me that every year I lose 20% of the car's value. How do you find what the value is for year 1? What are the steps I'm going to have to take? Have any of y'all ever tried to calculate something on clearance? Figure out what the sell price is of something? What are the math steps you're taking?
Yeah, multiply the new car by the value of every year. We're like, oh yeah, I'm
You were multiplying something by something, yeah?
here. So I would multiply it 20%, 20% with 10 years.
So the first thing we're doing is we're multiplying whatever the current value is times 20%. So I'm going to write CV for current value times 20%, right? Once I find that, that's my value of depreciation. That's how much I have depreciated. Does that make sense? So this would be what I have depreciated by. Now, my cost of my car now, the value of my car is going to be different. The value of my car is going to equal its CV minus the depreciation. Does that make sense? So that's what I'm doing. I'm figuring out what is the depreciation, and then to find the value of my car, it's that current value minus the depreciation. Okay, so let me go to my handy dandy calculator. I'm gonna open up good old Sylvie, turn her on. I'm gonna reset her because who knows what she's been doing. And the first thing I have to do is figure out how much did I depreciate by. So I'm gonna take my 18,000, and how do I multiply by a percent in the calculator? Times what? 0.2, 0.20, right? You convert it to a decimal. And so my depreciation value is 3,600. So after year 1 of being on the street, my vehicle is now worth less than $3,600. Does that make sense? And less than means I'm taking what it used to be valued at and I'm subtracting 3,600. So what is my new value? 14,400. Okay. And I repeat these steps until I figure out 10 years. Okay. So now my current value is 14,400. After 1 year again, I lose how much, what percentage? 20%. So I'm going to take that 14,400 and I'm going to multiply it again by 20%. So this time my car value loses $2,880, right? So my new value is my current value minus that depreciation. So 14,400 minus 2,880. So what is my new value now? 11,520. Okay, so tomorrow when you come in, this is where you're going to continue as you're due now. You're going to fill in the table to figure out what is the car's value after 10 years. Do we understand the 2 steps we're following?
Yeah.
Yeah? Doable? Yes. We multiply, we subtract. We multiply, we subtract. Okay? Yes. Easy peasy. All right. Huh? Yes, I got it.
That's what happened to the boy test.
Did we not finish it?